Oh, no, I haven't pushed it yet, I'm sorry. So PS8, as I mentioned, you're going to be creating another client. So you'll be exercising your GUI building prowess. This will be a client for playing a game of Boggle using, by making REST calls to a server out online. So that'll appear tomorrow. So there'll be a server live online, and you'll just write your client against it. So not only do you need to know how to build a GUI, you need to know how to have that GUI communicate via the web with a remote server. So that's the main thing today, is to try to nail all that down. First thing I want to do is try to go back to the async await pattern and try a different way of explaining it. Because the way I tried last time didn't work out too well. So here's the thing. Here's a program. So no async await yet. Let me just give you the background. The idea is I've written this class to sort of simulate the action of a GUI event loop. So let's see what I have. I have a stopwatch because I want to be able to time how long things are taking. So that'll tell me how many milliseconds have elapsed since the program started. Then I have a list of events. Now, in this case, capital E event is just a class I created. It's not the built-in event keyword. So I have a list of events. And then I have this event loop method, which is the main method, the main method calls it. And all it does, oh, no, sorry. That's the constructor for the event loop class. It initializes a stopwatch, and it creates a list of events. So the idea is, this tells what this simulated GUI event loop is supposed to do. Remember, the GUI event loop is supposed to just wait until something happens and then deal with it. Button is pressed, deal with it. Menu is pulled down, deal with it. Well, I'm simulating it, so this just says, after 1,000 milliseconds, my simulated loop should run that delegate. After 2,000, it should run this delegate. After 3,000, it should run that delegate, and after 4,000, it should quit. So I'm just making a schedule for my event loop. It's just a simulation. All report does is print out that string, but also, before it prints the string out, it prints out the number of milliseconds that have elapsed. So if I simulated those 4 events, if I ran the simulation of them, what would you expect to happen? Console would pop up. What would be printed to the console? Yeah?
Probably nothing initially, and then a second after one of the strings.
Okay, so nothing would happen for about a second. So after 1,000 milliseconds went by, that's 1 second, we would see, it would print out 1,000 milliseconds have elapsed, and it would say 1 second. After another 1,000 milliseconds elapsed, you'd see something else be printed out. So you'd see 3 things printed out, and then it would quit after 4 seconds. All right, we'll see how that works, but let me just run it here, and you'll see what I mean. Okay, so 1 second, 2 seconds, 3 seconds, 4 seconds. Okay, so why did it print out 1 second after 1,001 milliseconds instead of doing it after 1,000? Yeah?
Delaying the event happening?
Yeah, I don't know. Yeah, so just the timing wasn't exact. By the time it really got around to that much time elapsed, but close enough. Okay, so let's see what it's doing. Here's my here's my loop. So what the loop does is it starts the watch, and then it just starts looping. And each time through the loop, it goes through every event on the event list, and if it's time to execute the event, it does so. Runs the delegate, or if it's a quit, it actually returns. So if it's time to deal with the event, it deals with it and then removes it from the list. So the list keeps getting shorter as time goes on. And this loop is spinning around, and at the bottom of the loop every time it sleeps for 1 millisecond. So every millisecond it wakes up, sees it's time to do something. If it is, it does it and deletes it. Goes back to sleep for a millisecond. Wakes back up, and on it goes. Okay, now we just ran those just those 3 events. Now I'm going to add another one in. This one is this says that after 1.5 seconds, call the method G. Okay, so it'll print out 1,000 1 second, presumably it will, after a second and a half, whatever G does will start happening, and so on. Right? G is an abstract method, so I can redefine it in various places. So I'm going to go and look at version 1. So this is version 1 of G that we're using. So look at it for a minute. So as soon as it's called, it prints out starting, and then it prints out calling H. And H is a method that creates a task. So it'll call H, and it'll get a task back. And that task will be running. Then it will print out that, confirm that H has returned a task. Then it will wait for the task to return its result and print out a result. It will obtain the result, it'll print out the result, and then it will report it's completed. When H is called, as soon as H is called, it will say that it was entering H. It will start the task, and then it will report returning the task and return it. And then as this task runs, you can see what the task does is it prints out starting, it sleeps for 2 seconds, then it prints out completing, and it returns 5. So my challenge to you is to figure out, predict, what will be printed out. That event loop is going to fire off the call to G after a second and a half. What gets printed after that? What gets printed in what order and at what times? So at 1500, G is called. See if you can predict what's going to happen. Who could help me out? Yeah?
I'd say immediately afterwards, you're going to see starting, calling H, and well then.
Okay. Yeah, so right away it's going to print out, right at 1500 seconds, it's going to print out G is starting, G calling H. Okay? That makes sense. What will we print out next?
H entering the task starting.
Now, G calls H, so it's going to say H entering. Right? That'll happen in about 1500 milliseconds as well. Okay? Then H creates this task right here. What will we see next? Yeah?
This is the part where we don't know. We can make a guess, but
Okay.
it's a probability guess and not like a hard,
Okay.
it'll always be this.
She's right. We don't know exactly what will happen because now we've got this task running. So it'll launch this task. That'll start running in a separate thread. And so it'll print out returning a task. And at about the same time, this task will say task starting. This may come before that or vice versa, but they'll happen at roughly the same time. All at about 1500 milliseconds. All right? So H prints out returning a task. This gets printed out soon after or soon before. When will this get printed out?
3.5.
Right, after 2 seconds, so at about 3500 milliseconds, that gets printed out. Up here, when will this be printed out? Let me scroll up so we can see. We called H, we got a task back. When will that be printed out?
Probably right after the task is started.
Yep, it'll say, right after, certainly after returning a task is printed, it'll print H has returned a task. Then, when will it print G, return value of task is whatever? Yeah?
After task completing.
After task completes, which is going to be about at a 3500 millisecond mark, then it will print out G completing right after that. That's what we expect. There's going to be a 2-second pause in there while the task completes. So let's run it and see how good our prediction is. All right, so it printed out 1 second. Let's just look at the 1 and 2 second and 3 seconds. It printed out 1 second at the right time. These were late. That should have happened at 2000 milliseconds. This should have happened at 3000 milliseconds. Why did they not happen until 3500 milliseconds, roughly? What happened to my event loop? Yeah?
G was waiting on H.
Right, G was blocked, waiting on that task that H created. And so the task loop was stalled. If G doesn't return, that event loop doesn't get to keep spinning. So the event loop was blocked for 2 seconds. So that simulates what happens when you have a GUI control that you click on, and it does something that takes a while. If you're doing it on the event thread, it blocks. It blocks the loop. So that's what that simulates. You can see at about the 1500 millisecond mark, it says G starting, G calling H. We entered H, and H returned a task. And at exactly the same time, in milliseconds anyway, G said it had returned. G reported that H has returned a task, and the task started. So the task is running in parallel. It took 2 seconds for the task to complete, and that's when G said return value is 5, and that's when G said completing. And finally, the event loop got its control back, and it was past time to print out 2 seconds and 3 seconds, so it did so. And then at 4 seconds, we quit. Right? So we're simulating what happens when the event loop gets blocked. All right. How can we avoid? I would like to see 2 seconds and 3 seconds come out at the right time. But I also want G to be able to do what it needs to do, which is to wait for H to finish, wait for the task, rather, that H created to finish, and then print out the result value and return. So how do we avoid blocking the event loop? Yeah?
You're running on another thread?
Okay, we've got to run at least part of the body of G as a separate task. So we need to do that waiting on a separate task. We need to create a task to wait for that other task to complete. So what we'll do is go look at version 2. So I'll go back to the event loop here. Somewhere I've got to change to version 2, which uses a different version of G. Here's version 2. Let's see how I changed it. Okay, there, I didn't change H, I just changed G. So, as before, it reports G starting, it reports G calling H, it creates the task, all as before. But then what it does is it creates a task and runs it. And what that task does is report that H has returned a task, does that, gets the result, reports, and then that task completes. So now, how's that going to let the event loop keep running? Yeah?
Will the 2 second, 3 second run on time?
Say again?
The 2 second, 3 second run on time, this is on another task?
Right. G is going to get called and return almost immediately, leaving this task behind to run. When this thing completes, it will sort of complete the work that G was meant to do. In the meantime, G is returned, and the event loop is still spinning along, and things will happen on time. Okay? So let's see that in action here. 1 second, 2 seconds, 3 seconds, then it completed. So, if you ignore the 1 second, 2 seconds, 3 seconds, things happen in the same, at roughly the same time that they happened in the original program. It's just that the event loop wasn't blocked. So what that tells you is that to wait on something, if you need to wait on something, you better not do the waiting on a critical thread like the GUI event thread, or things gum up. But it's kind of a pain to have to do that. To have to take what was a straightforward method and put part of it in the body of the task that you set off running, and then leave it to its own devices in return. I'd rather not have to do that right there. So let me show you a different way. So this different way is version 3. And again, all I did was change G. And there it is. Let me run it. So now we're running version 3. 1 second, it does some stuff. 2 seconds, 3 seconds, it does the rest of the stuff. Quit. All right? So it's behaving the way version 2 did, but it looks a lot more like version 1. So the question is, how does this pull it off? How do we pull this off? Yeah?
Using async and await.
Okay, so you have to notice that this is declared an asynchronous method. And it uses an await. So the key thing is the await. If you use an await, you must declare the method that it appears in async. Okay? And the compiler will tell you if you don't. If you take that out, it'll complain. The question is, what does await do? And I'll tell you what it does. What this await does is when you await the task, it's sort of like doing task.result in that the result of awaiting the task is whatever the task returned. But what await does is it doesn't block the program. It creates a thread and runs it. It creates a task and runs it and returns that task as its result. Now in this case it's a void method, so there's nothing, the task doesn't have to be returned. So await packages up whatever is yet to come into a task. Starts that task running and returns. So it does for us automatically what we were having to do by hand in version 2. So it's a lot simpler. Just wherever you put the await, everything that would execute after that await gets packaged up into a task. And as soon as what we're awaiting completes, that task unblocks and runs. Yeah?
Does that mean you can only have one await necessarily per method, or can you have...
No, you can have multiple awaits. In which case, you hit the first await, it would create a task. If that task hits an await, it would create a task. Yeah. So if you want to write tasks, if you're using multitask, so you can do number crunching in parallel, okay? That's not what await is for. The await async pattern is for when you need to wait on a long-running method to complete. And rather than creating a task manually, like we did in version 2, you just have it create it for you automatically here. Yes?
Thread management, do we have to I'm thinking of system in, you would want to close that you were reading in something. Do we have to close threads? Do we have to terminate them?
You have to close tasks?
Yeah.
No, when they end, they close themselves up. Now, I showed you code that's simulating the event loop. What did G and H simulate in terms of, say, the kind of program you're going to be writing next week, where you've got client that's interacting with the REST service? Yeah.
H is the server.
Okay, H is, what H approximates are the methods that call the server. Okay. So there are methods like post async and get async and put async, which they call the server to, they make a call to the server, but they don't sit and wait for the server to respond. What they do is they return a task that does all that. So when you call post async, what you get back is a task. And when that task finishes, you'll have the result from the server. Okay? What does G approximate? Yeah, G approximates, let's say in the GUI, someone clicks on something that causes the post to happen. So it approximates the method that calls, there's got to be some method that calls post async, and then when it gets the task and waits for it to finish, and when it finishes, it updates the GUI. So G approximates that task, that method. So you'll be writing methods for every action. You'll have a method that calls the appropriate REST method, waits for a return, updates the GUI. You don't want to block the GUI thread, so you'll be using an await to avoid blocking the GUI thread, rather than creating your own task from scratch. Much simpler. Now, I want to show you a couple other examples of this. So what I have is async await 2. So let me make that the startup project, and we'll see what that's about. Okay, this time we want G to return a result. right? Before, whatever result we got back from the task, we just printed it out, but now I want to return it. So, how do we deal with an asynchronous method that needs to return a result? Normally, we would declare G to be of type int, right? It returns an int. You see it right there. But what's it say up there it returns? A task that produces an int. Why do we have to declare it that way instead of just int? Why is this misleading? You look at that and you say, oh, it's returning an int. Why is that misleading? Yeah?
Is it because it hasn't actually gotten it yet? And it's
No. Look at the await. When it hits that await, what does it do? What's going to happen? It's going to package up the rest of the stuff that hasn't run yet into a task, which, when it completes, will produce an int as its result. So we are, because of this await, what we return from G is a task that produces an int. So that's why it's declared that way. Okay? Now, in my event loop, I don't do anything to that return value. So let's go to the event loop that goes with this version. Here's the event loop, and it calls, well, it does do something. It reports return value of G as G.result. All right? So what's going to happen when we run this? And clearly, it's going to print out 1 second. The question is, when's it going to print out 2 seconds? Got an idea?
Probably on time, but before return value of is printed.
Okay, well, let's think how that could happen. So we're running this method here, report, on the GUI event thread, right? This delegate's running on the GUI event thread. This returns a task. But we got to wait for the task to produce a result. We're blocking while that task produces a result. All right, so given that information, what's going to happen here? Will 2 seconds be printed on time? No, I don't think so. I've been surprised before, so let's see. Okay, so it got blocked. Now, why didn't it get blocked before in our original version? Why wasn't there a problem? Yeah, so if we go look at the original event loop, which is right here, we're calling G, but we're doing nothing, we're doing nothing with the return value. In fact, there is no return value. There's nothing to block on. But in this new version, yeah, G returned, but our return's a task, and if we're going to sit there and wait for it to finish, we're going to block. So, what can we do? How can we make it so this thing here, this delegate, doesn't block the GUI event thread? Yeah?
Put it on a new task.
Well, we could put it on a new task, but I got a better way to do that. Okay? So, generally, if you are waiting for the result of a task by saying .result, well, don't do that. Await it. So now the delegate will return as its result, it will immediately return a task that eventually will print out the report. And the GUI event thread can go on. Now it's going to complain here because the await operator can only be used in an async method. Remember, if you have a method, you have to declare it async. This delegate's no different. You have to come up here and say, this is an async delegate. And now it's happy. So we don't have to create a new task to wait for the result. We just say await G. It creates the task. The delegate returns immediately. The task, when it eventually completes, is going to report out return value of G is. And the loop goes on. So here we go. Finally, that delegate finishes. So you can cascade these awaits. So it's really easy. If you're saying task.wait or task.result, you're blocking. Don't do that. Say await task. And you know, if your method before was returning an int, now it's returning a task event. Really nice. Now I'm going to put this back the way it was because there's another project. Async await 3 right here is just what it contains the edit I just did when you look at it. Okay, so that's the story behind await async. Yeah?
What would happen if you had made it wait 3 seconds so that it was scheduled to print at 4 seconds, 4.5 seconds, but you also called it quit?
What happens if the main program terminates before that task gets a chance to complete? Okay, so there we're sort of getting into more obscure details of the way tasks work. But typically, depending on what kind of program you create, some tasks, some threads are designated when this one dies, the whole program dies, along with any tasks that are continuing. So, in fact, the console app that I wrote here, as soon as that main thread dies, everything else goes away too. So that task would die before it get a chance to print out. We would have to go. I don't even know how you overwrite that behavior. There is a way. Yeah?
Can constructors be declared async or no?
Can constructors? Well, I doubt it because what would the return type be? A task that produces the. Try it out. I hadn't thought of that. I think it has to be enough. Now, last time, let's see, we're here. Okay. Last point I'm going to make here is, here's this client program. There were 3 versions. Controller 1, Controller 2, Controller 3. The problem we got with Controller 1 is, I think I fixed it by the way. Let's see if it stayed fixed. So I've got right here a server. I'm going to start it. So I'm running my server now. It's happily running. Here is my client. I'm going to start it. And the idea is, what I told you last time, if I say my name is Stahl, and I give something for the email, the server will just, to help me make a demo, will block for 5 seconds before it returns. So I'm going to say register, and you see these buttons aren't it takes 5 seconds for the interface to unblock. There, it finally, no. Yeah, I had to click there before. So it stalls for 5 seconds. It blocks the GUI event loop. So how do we fix that? Let me go show you where the problem is. This is controller 1. What we're calling is the register method. Down here, there's the register method. Let me make this bigger. So where is the block happening? Right, this post async is calling. The server's taking 5 seconds to return. In the meantime, our thread is blocked, waiting for the result. Later on, actually, it could block here when it's trying to get the string. So there's 2 places it could block. Now, this is one version. The second version of the controller fixes it by, manually creating a task that, that does the waiting and returning immediately. How can we fix this with await async? Yeah.
Remove the dot result and instead do await.
Okay. So right here, instead of saying dot result, we'll just say await. What else do we have to do? You change the header so this is an asynchronous method. Done. Now if you want to fix this other place down here, my experience is that never really blocks, but we could put another await right here. Done. So now if we run this, if I've got good karma, we'll see this ought to when I say stall and enter email, and I say register, that cancel button will work. It doesn't say anything, but I do. Okay? So we took that problem of it blocking and fixed it just by judiciously putting in a couple of waits and an async. Anyone can do that. It's a lot harder to try to create a task by hand. So if you will look at it later, again, I'm going to undo the changes I made to controller 1 because they're changed. So that's controller 1. Controller 2 right here is like controller 1, except it does the explicit building of task. And controller 3 is what we just saw. It uses await async, the way I just demoed. It just puts those 3 things in. Yeah?
Let's say like you did your due diligence and actually put in the async and the awaits. How would you like catch that debugging if you're, you know what I mean? If you saw a problem, how do you catch that and find out where it is?
Well, okay, that's a good question, because what's actually happening is your program is being sliced up into, and being run on different tasks. So yeah, you can set breakpoints just like before. It's just they may not be hit when you expect, right? So it might take 2 seconds longer than you thought. When it does hit the breakpoint, it'll be hitting the breakpoint inside some other task. But yeah, the same kind of confusion can arise when you set breakpoints. If you have a yield return iterator and you set breakpoints in there, that's also being sliced and diced and turned into something else, and the breakpoints happen in weird places. So it can be confusing. Any other questions? So does this have anything to do with your next assignment? Now, one of the things you'll be doing is put in a cancel button. And the thing about cancel buttons, the cancel button is to cancel something that's taking too long. But if the thing that's taking too long is blocking the event thread, the GUI, the event loop, cancel button won't work till it's too late. So, to make it work, you just have to await async as your friend. Also, on the final, I love to put question like, I give you an await async example and say, in what order are things printed out? So, at least got to understand it well enough for that. Are there any last questions? Yes?
So if we're using await, and it's awaiting for some item to be assigned to something else, and it's continuing on, just waiting for that, and then later on, it takes a value and assigns the awaiting to the awaited item to it. Let's say that was defined earlier as a different type. Does it do the first one, or does it block until it's returned the item in the awaited thread?
I'm having a hard time following that. Maybe you could ask me later. But that reminded me, there is one other thing I wanted to say. If you do, suppose that you're in a GUI, you got a GUI situation here. In fact, let's go look at controller 2. Okay, so here's controller 2. We go down to its register code. And you can see this is where we created the task to run. I didn't do it exactly the way await would, but I create a separate task to run the body of the, to do the waiting for me. But then, one thing this thing does is it has to update the view. It has to set view.isUsuregister to true. So it has to update the view. But if we're changing some view component, it has to be done on the GUI event thread. It can't be done on some other thread. And so I've taught you that what you do is the invoke. You have to take the thing you want to do, turn it to a delegate, and invoke it on a GUI object, and then it will happen eventually on that thread. If you use await async, that is done for you automatically. If the await async happened on the GUI event thread, the new task that gets created will itself run on the GUI event thread eventually. So it saves you from that pain as well. It's just an all-around win. I've been told that JavaScript is adopting this. Maybe it has already, so it's starting to show up in other languages. All right, let's take a break and look at something different. All right, let's get started again. Okay, so if I can get you now to focus on PS8 instead of PS7, you'll have fewer questions next week. All right, so here's what's going to happen. When I publish PS8, sorry, I said I would put a server up. It'll provide a REST service that lets you do various things related to playing Game of Boggle. And so the first thing you'll need to do is understand the API, the REST API that is provided, before you start writing a client against it. So what I'm going to do is show you the to-do list, sort of show you the analogous thing for this to-do list example. So there's the to-do list. And like we saw last time, you know, I can enter, I sort of have to register, so I say Joe and I give it some email. Oops. I give it some email, which really doesn't matter. And I hit register. So now I'm registered as a user. And I can do a task like mow yard. And I submit it. And it says mow yard. And it gives me a button here, X. I can click that to delete the task, or I can click done to mark it as completed. It's not the slickest GUI in the world. Things don't line up quite right. If I, you know, register under a different name, and I say something like shovel snow, submit task, okay, it updates, and the other task disappeared because that's not my task. I'm a new user. But if I say show task for all users, it shows me all the tasks that it knows against one I created earlier. But the only ones that I can actually delete or mark done are my own. Okay? So how many REST calls do you think my server provides to support all that? Oh, let me just say, I don't need any, I know that there are problems with this. It's not secure. It doesn't update properly all the time. So it's just sort of a proof of concept. So I don't need questions about that on the also. I know it's kind of a crappy thing. I expect more of you. Yeah?
You have 5, like 1 to post register.
All right, so register is 1.
1 to post the task.
1 to put a task, add a task.
1 to delete.
1 to delete.
1 to be done.
1 to mark completed.
And
That's right. And I'll just tell you the 5th one. The 5th one, you just call and it gives you back all the tasks that you should display. It depends on how these boxes are checked. You know, if I say show only my tasks and show only completed tasks, there's nothing. If I now mark it completed and I say show only my completed tasks, it'll still show it. If I delete it, of course, it'll go away. Okay, so the API provides 5 endpoints. 5 ways I can interact with the server. So now the question is, what are those endpoints? All right, so I spent a little time since last time and actually created documentation. And this is the documentation for the to-do list API, and you will be seeing a similar form of documentation for the Boggle server API. So let's see, it says first of all, right here, the URLs below are relative to blah, blah, blah. So that just means that if you're trying to contact the server, that's its base address, and then you provide the rest of the RPI is described in here. The rest of the URL is described down here, but the URL always starts with that stuff. Okay? So there's that method. I'll just scroll through it quickly. There's register. There's add item. There's mark item completed. There's delete item. There is get all items. So those are our 5. So let's just look at one. So what can you tell by looking at register right here? What's the documentation consist of? And there's a description of what it does. So if these are the inputs. So if main is null or empty, then it's going to respond with 403. So the response code will be 403. On the other hand, otherwise it creates a new user and returns a unique ID for it. And returns status code 201, created. So it either fails or succeeds, depending if you give it a good name or not. Is this a post, a get, delete? What is it? What kind of verb do we use to run it? Right? It says it's post. What about this? What does this mean? What's that? Yeah?
It's the thing that goes in the URL.
Right. That's the end of the URL. That's the rest of the URL. So remember, the first of the URL was HTTP blah blah. So after that last slash, you would put register user. And that would be the URL you would use to register a user. So you need to send that URL with a post request. Yeah?
It says if name is null or empty when trimmed. What does it mean by when trimmed?
When you get rid of the white space from the beginning and end.
Oh, okay.
So if the name, basically that's saying if the name is all white space. All the white space gets trimmed away. Okay, so it's saying you need to issue a post request to that URL. It's saying the input, there are two things, two pieces of input, name and email. And it gives you an example of how you would do it. I should say post register user, so there's a mistake right there I need to fix. But what is this saying right here? How do the parameters get to the post method, to the post request? This shows you what you send in the body, right? This is an example of what you send in the body. There'll be a name and an email, and both of those are strings. What is this thing here? That's just a JSON. That's just an encoded JSON object. So it's basically, you create an object that has a name and an email, and whose values are strings, encode that as JSON. That's what you send to the post request. And it responds, at least in this case, it would respond with the status code of 201. And, that's a string, that doesn't belong there, that quote mark. This is the ID number that it returns to identify the user. That's a user ID number. So what's returned is not a JSON object in this case, it's just a string. So now you know what you need to know about registering the user, about that endpoint of the API. So let's suppose you're a little bit unsure about how to use register user. What could you do? Just start coding and hope it works? Yeah?
It interacts with like a REST client.
Right. We'll go use something. I'm going to use the advanced REST client. It's an app you can go into Chrome and search for advanced REST client and get the advanced REST client. It just lets you, we've seen this before, it gives you a way to experiment with a REST server without having to write client code. So let's see what I've done here. Look at the URL up there. Look familiar? Right? That's the URL we would use for register user. I have picked the method to be post. So in the advanced REST client, I enter the URL here. I want to test register user endpoint. I picked post from among those options. I set this header here. Let's look at the headers. I'm setting content type to application JSON. So I'm saying that I'm sending JSON and I expect to get JSON back. So I've set those two headers. And what else did I have to do to call this post method, to call post? What else do I need to provide? What did the API say? Right, I had to provide a JSON object, and there it is. So you can sort of type it in by hand if you want, but there is support for, that's what it looks like as raw input. You can also have a visual editor where you just give name and properties. Okay? But anyway, you won't, that's the JSON object we want to have. And once you've got all that detail, so you've said what goes in the body, you said what the headers are, you said what the URL is, you said that it's post, you can send it to the server, and it responds with 201 created, and this string here is the unique identifier for the user we just created. Okay? So it ends with F7. Presumably if we issue this again, we've registered a different jack with a different ID number. Let's make sure we get back is different from that. Yeah, that's different. These are just randomly generated base 16 hex, a few hyphens stuck in. Okay? So that's how you experiment. And we have actually modified the server. I mean, the server now, we've modified the server's memory. It now is keeping track of these two users we created. So we're communicating it just the way the client would communicate with it. So this is how you debug your understanding of the API, through this. If you skip that step, you might succeed, but you might end up with a frustrating debugging session. It's a lot easier to debug your understanding of the server and of the REST calls here, where you can control everything easily, than from some C# program, where maybe the bug is in the C#, or maybe the bug is in the server, or maybe the bug is in your understanding of the server and you don't know. So definitely use this. Okay, any questions about that before we look at something different? Yeah?
What was the name of the software one more time?
It's called Advanced REST Client, ARC. It is a Chrome, is plug-in a thing, or they use a different term? A Chrome extension. Yeah.
Is it in the resources tab on the Canvas page?
I could put it there.
That would be pretty awesome.
Okay. But the way I found it was I just ran Chrome and searched for Advanced REST Client. And then it was there. All right. If I forget to do that, and I probably will, send me an email or post it to Piazza or something. Okay. So this is your friend. All right. Let's look at some more of the API. This is how you add an item. So again, it's typically the API will say, okay, if there's such and such a problem, it'll respond with status code 403. Or in this case, that's the only thing that can go wrong. In the bottle server, the specifications are more complex. There's often 3 or 4 error cases because there's more parameters, more things you can do wrong. And if you don't do those things wrong, you're not going to see those errors, but you will see them if you screw something up. In fact, let's go back here. Now that I've mentioned that, we will go back to the REST client. And what would happen if instead of Jack, I passed an empty string? What would you expect to happen if we try to register an empty string name? That was supposed to be the 403. If you send it a null or essentially an empty string as the name. And we do. We get back 403 forbidden. And that's something you can test for in your client code. You can see what the response code was and deal with it appropriately. All right. Let's go back and look at add item. So if the user ID is one that's unknown, hasn't been generated, it's going to say forbidden. Otherwise, it's going to add the item to the list and return the ID number of the item with response code 201. Okay, what kind of request is this? It's a put request, because it says so. Add item is the rest of the URL after the boilerplate at the beginning. It gets a user ID and a description as parameters. So, this says put, that says post. Wow. So I did this in the hour before class, so I was in a hurry. I think it's a put, actually. We'll find out in a second. So the body of presumably the put. Oh, maybe someone's taking notes of everything wrong here. If someone did, I would like to see your notes. It's going to be a JSON object with user ID colon, a valid user ID, and then the task no yard. Okay? Let's see. Let's see if we can add an item. Oh, that's the wrong place. Let's try to add an item to using this over here. What do you have to do? Let's see. Add item. We think it's a put. And what's supposed to go in the body? Okay, there's supposed to be a user ID. I don't know what we should use for that. And there's supposed to be a, was it description? Okay. Let's just submit that. What the heck? Okay, method not allowed. I guess that was a post. Okay, it's saying forbidden because we gave it a bad user ID. Rats. What's the correct user ID? I don't know. So let's go back to register user here. And we have to pass in a name. And we pass in Joe here again. We will send it. It sends me back a user ID. I'm going to copy it this time. You can save these things. You can see over here, I have some saved examples. You can save them. You don't have to go typing back and forth like I'm doing. So now let's turn this into a, what was it, add item? It's a post, and we're supposed to have user ID there. And we're supposed to have that thing there. And we're supposed to have description. And we're supposed to have mode. All right. That presumably will work. Let's send it and see. Okay, great. Like that user ID, it knows about it, and it's created the item for us. Now, if we were to go run the client, the GUI client, we would see that item exist. You got a question? Yeah?
So what if user ID was not user ID, or like you put a space between user and ID and the formatting wasn't right? Would that matter at all?
No, it depends on how carefully I wrote my code. Because my code is going to be looking for user ID. And let's send it and see what happens. Okay, we get the 403 because it did not find a valid user ID. Now, I don't think I wrote the code to really deal with description very well. Let's see if it did. So it created, I don't know, it created it, but I bet you it created it with an empty description because I didn't really give it a description there. So my server, this server wasn't written very defensively. The Bybar game server is more careful about making sure that you get all the right parameters and complaining if you don't. All right, well, that's easy enough. Let's see what else you can do in this thing. So that's add item. It shows you the response it expects to get back is 201 created. And, oh, we should have gotten back, yeah, down here we got back an item ID, which is like a user ID. So that's good. I swear I changed this to use reasonable item IDs. Huh. Well, I think I did, because I didn't refresh this. That's better. So item ID is, again, some big, long, globally unique ID. Okay, here's another one. Mark item completed. Let's see if we can read it. If the item ID is unknown, if it's not one that was actually generated by the system, it's going to complain. Otherwise, it's going to mark it as completed. And this is another problem. It's a put. I would say put up there. But, and it takes item ID as a parameter, but how do you pass in item ID in this case? There is no JSON object that's being passed to this one. So where's the item ID you're supposed to mark complete? Yeah.
In the URL itself.
It's actually supposed to be put into the body of the URL. So the URL is going to be mark completed / and then you put the item ID there physically. That's just another way that REST APIs mix it up. Sometimes the information comes as a JSON object, sometimes in the URL, sometimes some of both. So that would mark it completed. So let's see, mark completed is a put. Let's go see if we can do that. So we don't want add item. We want mark completed. We don't want post, we want put. What else do we put up here?
Copy down.
This item ID before it disappears on us. Oops. I didn't quite copy it right, so let's paste it here and get rid of the quote marks. So for whatever reason, I decided to do it that way. And we don't need the thing in the body. I don't think it'll cause any problem to pass it. I don't feel like deleting it. So presumably, this will do the mark completed method on the server, and it will mark that item we just created as completed. And as long as it doesn't balk about this thing in here, if I send it, Okay. So it got marked as completed. There's no other return value. It just says okay. All right? So you're really going to have to do this for all of the endpoints in the homework API. I really encourage you to use them to make sure that you understand how they work. And you know, when you do it, you're basically going to be simulating the play of a game of Boggle in a clumsy fashion from the advanced REST client. But it's surprising to me how many people get so far into the project and still don't understand the API. Right? Here's delete. How does it work? How do you delete an item from the list? Yeah?
It's just the same fashion, you just specify the delete item in the URL.
Right, so the URL has the item ID in the URL, just like before. The HTTP verb in this case is delete. So we call delete, there's our URL, and there's nothing in the body. This is just an example. We're going to delete something, we just do it that way. And I won't bother demoing it, it's going to be about the same as that put. We delete it off. Okay? And the last one is get all items. So this is a GET request, you can see it's a GET request. And it takes actual URL queries. So after the question mark, you say completed equals, and you put either true or false. So completed only is a Boolean. So you would say completed equals true or completed equals false, or leave it out entirely. It's optional. And then you put an ampersand and you would say user equals and give a user ID, or leave it off. And what it does, if you don't give any parameters, it just gives you all the items it knows about. If you say question mark completed equals true, it will just give you back the completed ones. If you say user ID equals some user ID, it'll give you back just the ones that belong to that user. So using those parameters, you can choose what you want to see come back. But they're all optional, so you can leave them out completely. And what do you get back? Here's an example call where we say completed equals true. So what are we going to expect to see? What do we expect to get back from this? Yeah?
A list of all items with the specifications you put in.
Okay, in this case, what we got back are all the completed items, because we said completed equals true. We got back this. Yeah, that's a list. What's another way to describe this thing? More specifically, what kind of list? Yes?
They're JSON objects?
Yeah, it's a JSON list containing JSON objects. So when you see square brackets, that tells you that's a list. And then you can see each element, there are two elements in the list, each is a JSON object. And so the client code that deals with this would have to know that, because it has to know what to expect so it can make sense of what it gets back. Okay? And you can see what comes back. Each object has an item ID, a description, a completed user ID. Let's see if we can run that. So go here. We need a GET request. And we don't want to do mark completed. What was it called? Oh, there it is. Get all items. And that's, I just won't specify anything. I want to see all items. So we should be able to do a send. And we got back 4 items. Okay? 4 items, completed, Mo, null. Remember the one I said it didn't create it with an empty description, it created it with a null description. So I didn't use defensive programming. Where are these others come from? Yeah?
We were using the UI earlier.
Yeah, I was playing around with the GUI client, and my server doesn't, the server that I'm using today doesn't have long-lived state, so when you shut it down, it forgets everything. It's not using a database. But it's been running the whole time without being shut down, so it's just 4 that I've created. If I take the same thing, and I say get all items, and then I say question mark, completed equals true, then it'll only show me the ones that are completed. So let's see, 2 of them are completed, so I should just get 2 items back this time. Oh.
You're missing
You
the
misspelled
L.
completed.
Oh. All right. Now I should just get 2 items back. Yeah, I get the completed items back. Okay. So that's understanding the API. It just takes a bit of experimentation. That, it'll really pay off if you do it up front and learn how it works. Then there's the problem of how do you access the API programmatically. Now we've talked about that before, but it's been a while. I showed you, I demonstrated accessing REST services from this advanced REST client, and I showed you some code that did it. But now, in addition, as an example, you have my to-do list client, at least once I push it up. And inside this is another good place to look before you start on your PLC. Because it contains, the controller has a method that registers a user. Let's see how it works. It's doing some user interface things like enabling controls, but basically it creates a user object. This is an example of how to deal with cancellation as well. But it creates that object, it encodes it as a JSON string, it calls post-async, passing the content along. It's using the URL right here. That's the URL. My code's written, so I just provide the rest of the URL. We're doing an await to wait for the response to come back. So this thing is cancelable. When we get the response back, we say, well, was it a success? So to 200, 201, anything that starts with a 2 is a success. If so, this code grabs the string and stores it in a string variable, because we know we're expecting a string back, not an object. Remember that. We cast it to, this completes it. We deserialize it, turn it to a user token to remember it, and remember that the user is registered. Otherwise, we pop up a message box saying what the error was. All right, that's just all details, right? But important details. So when you need to know how to do a post request, there's your example. So I have one example, I have an example of register. There's submit, that's another post. Delete, that's a delete call. We have done, mark done, that's a put. And the last one we'll look at here is the get request. So let's just look at it. It creates a URL depending on what the choices are. Do we want to show completed or not? It just decides what parameters, what query string to include. So it builds the URL. It does the get request on the URL. This one, I somehow missed the await. There's obviously an await result here. I somehow messed that up. I'll have to fix that too. I've got a lot to do after class. Then we look and see if we succeed, if it's success. So let's look at that. What are we doing in the case of a success? Well, we're grabbing the result string. We are deserializing it and storing it to a dynamic variable. Now, how do we know what type of thing is in that items variable now? Because it doesn't say list, it doesn't say object, it doesn't say string, it doesn't say int, it just says dynamic. To use it, to do something with it, we have to know what's in it. How do we know what's in it? Yeah?
The API.
The API tells us to expect a list of objects back. So we just trust the API. We assume it contains a list of objects. And if we're wrong, we'll get an exception when we try to use it as a list. So we iterate through it. So if it's not a list, that's going to cause a problem, but it is a list. And each time through we pull out an item, which is again a dynamic variable. Well, when we pull items out each time, what will we be pulling out? How do you know what is going to be in the list? Same answer as he had before. The API says to expect objects. But what else did it tell you besides the fact that it's a list of objects? The properties. It told you to expect 4 properties: user ID, a completed property, the description, and the item ID. And so we can confidently, if we trust the API, we can look at the item description, the item completed, the item ID, now we can do all that. And again, if we're wrong, or if we spell this wrong, which I often do, it'll compile just fine. You're getting an exception when it runs. And it'll be kind of mysterious because you're used to that sort of thing happening in Python. If you program in Python, you find out about type errors when you run the program. You're not used to that happening in C#. When you use dynamic variables, suddenly the type checking is happening at runtime, not at compile time. So type errors turn into exceptions. So that's the game plan. Yeah?
What is the double equals at the end there doing?
When I view.add item expects a string, a boolean, and a boolean. So this is just testing to see if the current user is the owner of this task. Okay? I'll make your life easier on the assignment. Yes, you got to write a GUI. I'm not going to prescribe how you write it. So if you think that separating the view and the controller the way I asked you to on PS7 is a stupid idea, you don't have to do it. You can structure it any way you please. We're pretty much just interested in, does your thing work? Okay? The design is up to you. Any last questions? So just briefly, what's coming up? Next week, we'll turn our attention to building servers, because that's PS9. And then after spring break, we'll turn our attention to databases, because that will be part of PS10. So we'll be sort of fighting to cover enough so you can do the next assignment for 2 weeks. Okay, see you next